4-3, Part 1, Triangle Congruence by ASA and AAS. So in this video, we're going to concentrate only on the ASA, which stands for angle, side, angle. So we're going to show how to prove two triangles congruent using two angles and one side now, instead of two sides and one angle. So the objective is to prove two triangles congruent using the ASA postulate. Now, we already know that triangles are congruent if two pairs of sides and the included angles are congruent. This was your side angle side postulate we learned last video. However, you can also prove triangles congruent using other groupings of angles and sides. So our focus question for this lesson is, how is the angle side angle postulate different from the side 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 and the side angle side postulate? Alright, so it says you can prove two triangles are congruent without having to show that all corresponding parts are congruent. In this lesson, you will prove triangles congruent by using one pair of corresponding sides and two pairs of corresponding angles. Alright, again, there's really no new vocab for this, but I do want you to write down the angle, side, angle, or ASA postulate. All right, I want you to write this down in your notes. Treat this like a vocab word. You need to know what it is and know how to use it. So the postulate in words says, if two angles and the included side of one triangle are congruent to two angles and the included side from another triangle, then the two triangles are congruent. All right, here's a graphical representation of that. We have two triangles here. We have ABC and DEF. All right, so as you can see, they've marked angle A congruent to angle D. All right, that's what they say right there. Angle C is congruent to angle F. That's what they've got there. And then side AC and side DF are congruent. That is enough information to tell us that the two triangles are congruent. Now, the important thing with the angle side angle postulate, just like the side angle side postulate, all right, well, similar, not exactly alike. The important thing to remember here is the side has to be the side included between the two angles. Okay? If you use angle A and angle C, you have to use this side of this triangle. You cannot use side AB or BC. It has to be the included side. An easy way you can use to remember this is your side has to touch the vertex of each angle that is congruent in each triangle. All right. So in this case, we have to use side AC because we're using angle A and angle C. Okay, so we have to use AC. Just like in the second triangle, since we're using angle D and angle F, we have to use side DF. There's no way around it. All right. So like I said, you have to use the side that touches the vertex of your two congruent angles in both triangles. All right. You have to use the side that touches the vertex of your congruent angles. All right. I think I've ran that into the ground enough now. So let's do a quick problem here. It says, which two triangles, meaning out of these three right here, which two triangles are congruent by the angle side angle postulate? Explain. So kind of a little three-step thing here. So this, from the diagram, we know that angle U is congruent to E, which is congruent to T. We know that angle V is congruent to O, which is congruent to W. We know UV is congruent to OE, which is congruent to AW. All right, so that's the information we know. Now, what we need to use the angle side angle postulate, we need two pairs of angles and a pair of included congruent sides. Okay? Because that is what the angle side angle postulate requires. Two angles and the included side. So Here, we already have pairs of congruent angles. So identify the included side for each triangle and see whether it has a congruence marking. All right, so in triangle SUV, UV is included between side U and V, and it has a congruence marking. Right there, that's the congruence marking, that little red line. All right, in triangle NEO, EO is included between E and O, and also has the congruence marking. Okay, but now if you look at in triangle ATW, line TW is included between T and W, but it does not have a congruence marking. All right, it does not have a congruence marking. So therefore, since we have two congruent angles and a congruent included side, that means that triangle SUV and triangle NEO are the congruent triangles, and triangle ATW is left out in the cold. All right. Now, like I said, the important thing to remember with the angle, side, angle postulate is the side has to be between the two congruent angles. It can't be next to one of them. It has to be between both of them. All right. It has to touch the vertex of each of the congruent angles. Okay. Just like here, just like in this example, UV is our included side because it touches the vertex of U and the vertex of V. Over here, OE is our included side because it touches the vertex of E and the vertex of O. Here, our included side is actually WT, not the one they marked. So that is why we can't use this one, is because WT, since it is the included side between T and W, since it is not labeled as congruent to these two sides, that is why we cannot say that this is congruent to the other two triangles, because it is not the included side. Okay, let me write that. This is not the included side. All right, not the included side. So we can't use it. All right. Let's see if you got it real quick. Let me move my little box out of the way. It says, which two triangles are congruent by ASA? So here we have three new triangles. Figure out which two are congruent by angle, side, angle, and explain. So pause the video, take a few minutes, figure this out. All right, let me extend the page a little bit. So now, which two triangles are congruent? All right, for angle, side, angle, we know we need two congruent angles. All right, so here we have G, angle G is congruent to angle I, which is congruent to angle C. We have angle H congruent to angle N, which is congruent to angle A. And then we have side HG, which is congruent to NF, which is congruent to AC. All right. So we know we have pairs of angles and congruent sides. Now we have to narrow down which of these sides is the included side between these angles. All right. So if we look, we know HG is congruent to NF. So if we look at HG, is HG the included side? Yes, it is. HG is the, and we'll call it the I.S, included side. NF, is NF the included side between the two angles that are marked congruent? No, it's not, because N and I are the congruent angles, but NF is the side. So this is not the included side. All right, now let's look at AC. We can't just, so we've ruled this one out. It's not the included side, but we still need to check this one just to make sure that it is the included side. All right. So if you look, you have angle A and angle C. All right, and if you look, you have side CA. It touches the vertex of each angle. So yes, this is the included side. All right, that is the included side. So let's write our congruent statement. We have triangle GHO is congruent to triangle. Now we need to make sure we write these vertices in the same order for this triangle. I started out with angle G. One angle in this triangle is congruent to angle G. Well, if you look, this has one arc, angle C has one arc, so it's angle C. Then I went to H. H has two arcs, A has two arcs, and then the final angle. So triangle GHO is congruent to triangle CAT. All right. So you remember that focus question from the beginning? Because I'm making this a shorter video for y'all. Remember that focus question? How is the angle side angle postulate different from the side 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 or the side angle side? Well, here's our answer. Hopefully you've already got this. It says if you use angle side angle to prove that two triangles are congruent, you only need to know one pair of corresponding sides. These sides must be included between two pairs of congruent corresponding angles. So this is different from the side 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 or side angle side because you only need one pair of sides. All right. So not only that, you need two pairs of angles. Side side, you don't need any angles because if the sides are the same length, the angles got to be the same. You can only take three sides and orient them into one specific triangle. And then the side angle side, you need two pairs of sides and one angle, where the angle side angle is kind of the reverse. You need two angles and one side. All right. Here's sticking in the door. Number one, in triangle RST, which side is included between angle R and angle S? Number two, in triangle NOM, NOM, NO is included between which angles? Number three, which postulate or theorem could you use to prove triangle ABC congruent to triangle DEF? Number four says how are the angle side angle postulate and the side angle side postulate alike? How are they different? That one you can actually skip. And then number five, your friend asks you for help on one geometry exercise. Below is your friend's paper. What mistake did your friend make? Explain. All right, so answer these four questions, 1, 2, 3, and 5, because you don't have to do number 4. So answer these four questions and make sure you have them ready to go when you come to class tomorrow. Good luck.